Okay, so our warm-up for today is going to be graph the following inequalities. So we have x is less than -3 or x is greater than or equal to +4. So we're going to graph this piece by piece. Our first inequality, x is less than -3. I'm going to draw an open circle on my number line at -3 because it doesn't say less than or equal to, it's just less than. So we want to go all the way up to -3 but not include it. And less than, the numbers less than go left on the number line. Then we have another section or another inequality. It says or x is greater than or equal to +4. So at +4, I'm going to draw a closed circle. We're going to fill it in because we get to include +4. It says greater than or equal to. And everything greater than goes to the right. So every single number on the number line that is shaded either in purple or in blue is going to be a solution to that set of inequalities. Okay, so or means either this can happen, either purple can happen, or blue can happen. Now let's look at the next inequality. It says x is greater than or equal to -3 and x is less than +4. And means that both things have to happen. Both of them. They both must happen. So I'm going to take this one first. X is greater than or equal to -3. I am going to put a solid closed circle there because it says greater than or equal to. And greater than is shaded to the right. Our second part of this inequality says x is less than +4. We're going to do an open circle, and then we have to shade everything less than 4. Now, where do both of these colors overlap? And always means that you must have overlap. That's what and tells us. They both have to happen. So I'm looking at my number line, and everything up from -3, including -3, all the way up to, but not including +4, are part of our solutions. So this is how we would write this as an inequality. We would say -3 is less than or equal to x, which is less than +4. So this inequality up here is the same thing as this one down here. They mean the same thing. This is called a compound inequality, and this is generally how you're going to see your answers written. So let's solve absolute value inequalities. This first one, example 1, says the absolute value of x is greater than 4. What does that mean? It just means that the distance from 0 is more than 4 units away. So if this is 0 right here in the center, I want to be more than 4 units away. So everything bigger than +4 is more than 4 units away. And everything less than -4 is more than 4 units away. So that's what our number line answer would look like. But if we are writing our answer as an inequality expression, we would say x is less than -4 or x is greater than +4. Now you might be asking yourself, or me, whatever, Ms. Guidry, or self, how do I know it's an or problem and not an and problem? Anytime you are solving an absolute value inequality, if your absolute value expression is already isolated, which it is right here, then you're going to look at your sign. If that says greater than, it's an or problem. If it says the absolute value is greater than, it's an or problem. And there's a goofy way that I like to remember it. Just spell out the word greater. Greater. Obviously, that's not how you spell greater. It's usually ER, but that helps us remember. A greater than problem is an or problem. If you look at your second example, the absolute value of x is less than 4. That means the distance from 0 is less than 4 units away. So we're going to put our open circles on -4 and +4. And we want everything in between because we want to be less than 4 units away from 0. That's the overlap. So from -4 to the right and +4 to the left, they overlap in the middle. Okay, so that's going to be -4 is less than x, which is less than positive 4. And you might be asking yourself again, self, how do I know it's an and problem? Well, our absolute value expression is already isolated. This says absolute value is less than 4. A less than problem is always and this is the goofy way of writing this one. Less than. Obviously, that's not how you spell than, but still, that's how you can kind of remember which one is greater and which one is less than. Okay? So let's just read over our steps really quickly. When we're solving an absolute value inequality, step number 1, you're going to isolate your absolute value expression. We've already done that when we were solving equations. And then you just need to decide if it's an and problem or an or problem. So that's our first step. Our second step is going to be to write an inequality without your absolute value. So we're just going to rewrite our inequality, but we're going to drop the absolute value bars. Our third step is we're going to write our second inequality without our absolute value bars, but this time we have to flip our inequality sign and change the sign of one side. And then, of course, our last step is going to be solve both inequalities. So, example 3. Is our absolute value expression already isolated? Yes, it is definitely already by itself. So we have to write our two inequalities. The first one is just going to be 2x plus 3 is less than 7. All we did was drop the bars. The second inequality is going to be 2x plus 3, but we have to make sure to flip our inequality symbol right here. It has to face the opposite direction. So now it's going to be greater than, and the 7 used to be positive, now it's going to be negative. So we wrote our two inequalities, now we just have to solve. Subtract 3 from both sides of our inequality, and that gives us 2x is less than 4. Divide both sides by 2, and that gives us x is less than 2. Solve our second inequality. 2x plus 3 is greater than or equal to negative 7. So minus 3 from both sides of our inequality, and that gives us 2x is greater than negative 10. Divide both sides by 2, and that gives us x is greater than negative 5. Now, is this an and problem or is this an or problem? Our absolute value is less than. So it's definitely an and problem. So when we sketch this on our number line, we have a negative 5. We have a positive 2. If you want to put 0 in there somewhere, go for it. So this first one says x is less than 2. I'm going to do an open circle because it's not including 2. It says just less than. And we're going to shade left for less than. This one says x is greater than negative 5. So open circle, and I'm going to shade everything greater than. And tells us they have to overlap. Where do they overlap? In between negative 5 and positive 2. So as an inequality, our answer would be negative 5 is less than x, which is less than 2. So you have your answer choice as a number line right here, and your answer as an inequality right here. All right, let's do another one. We have example 4. It says the absolute value of 3x plus 1 is greater than or equal to 5. So the first thing we have to do, decide, is our absolute value expression isolated? Yes, it is. Is this a greater than problem or a less than problem? This is a greater. Whoops, I meant to make that a big O. Greater. Come on, right. This is a greater than problem, greater. So we're going to write our two inequalities. The first one, just drop the absolute value bars. That's all you have to do. 3x plus 1 is greater than or equal to 5. Our second inequality is still going to start out with 3x plus 1, but we need to flip our inequality symbol to less than or equal to, and our 5 needs to become negative. And now we'll just solve for x. So minus 1 from both sides of our inequality. 3x is greater than or equal to 4. Divide by 3, x is greater than or equal to 4/3. Doesn't reduce, I'm just going to leave it as 4/3. Our other inequality, when we solve for x, minus 1, that gives us 3x is less than or equal to, what's negative 5 minus 1? That gives us negative 6. Divide by 3, and that gives us x is less than or equal to, negative 6 divided by 3 is negative 2. So we have those two values, those two inequalities. We know this is an OR problem. So when we draw the number line, I know I have a negative 2, I have a positive 4/3, and 0 is somewhere over here. So when we graph this first one says x is greater than or equal to 4/3. So closed circle, and we have to go greater than. Our second inequality says x is less than or equal to negative 2. So closed circle, and less than goes in the opposite direction. And because this is an OR problem, they don't have to overlap. So this right here is our number line solution. And generally, when you see your inequality solution, you list the smaller numbers first. So x is less than or equal to negative 2, or x is greater than or equal to 4/3. And that's all